Hello everybody, welcome to another stream. How we doing? So, last stream we were getting the clusters and the spheres within the clusters binned within tiles. And then we got the Raytracer up and running. But there's still some bugs. I should have put the wrong one. So I just want to tackle some of those bugs today, and also, to see where we get to. So we should be able to get our full volume rendering today. So just disable the view, the view from wild stuff. Let's just make it so it doesn't have the camera controls. And as you can see up here, we have a cluster being rendered. Now I'm specifically trying to render the first cluster, like LOD 0. And I'm basically just rendering it and saying it's got a full set of spheres, and then it's just getting binned and everything. So here's the code here. I'm just saying, hey, with the first LOD, say there's 64 spheres, and just do all the binning as a debug test. Because right now, what's really weird is I don't have any. It shouldn't be where it is. Yeah, it shouldn't be where it is, because if you take a look at this world from local, it's got this 0x0y, 128 on the Z. So it should obviously be pushed further back, but it shouldn't be up here. That's just wrong. There's something wrong with someplace in the code, why it's putting it there. So I want to debug that today and see where else we go. So effectively, let's get that one up. So we're putting stuff into screen tiles. So if you've got this cluster, which is filled with spheres on the screen, we get the screen bounding box for it, right? A rough one. And then we try and, so we can use that to say, hey, how many tiles does it fill over on the screen, and then allocate enough spheres in all of the tiles, and then bin the spheres in there in a separate pass. But I think what's going on is this bounding box that we're making is not correct, and I don't know though. There's something that's wrong, so I need to figure it out, basically. So what we're going to do is yeah, so what I think I might do, yeah. So just print out two coordinates. X would have float, Y float. So we'll just do X, Y. So these are some test variables that we're going to use to figure out like what's going on. So basically, hey there, I can't even pronounce your name. I'll just call you wait, it's first stick. There we go. Hey first stick, how's it going? Welcome. So we've got a problem, I think, translating from view space into screen space. So we're gonna try. Maybe we'll just say right x and then y. So we'll imagine this has already been projected. Actually, no, we won't. Yeah, we'll have a z as well. So effectively, what you would do, say it's at 128 or whatever. Yeah. So what you'd do is just say x divided equals 0. Sorry, divided equal z. And then you need to then also divide it by the pixel size at near clip plane. And that'll get you into screen space. But I think these are not going to be correct. Like that should be in the middle of the screen, I think. Ooh. What is going on here? Oh, Y's already been declared. Whoops. Scope this out a bit. Pretty good. Been preparing for the last driving lesson tomorrow before the exam. Cool. I'm sure you got this covered. No, there's nothing to worry about. Also been a bit more motivated programming and learning how to do stuff. Code on Linux. Cool. Awesome stuff. So, yeah, the x and y shouldn't be 0. So we need to add the offset of the screen, which is what we've done here. Yeah, maybe it could have been my my local space code was probably off actually. This is probably correct code. Yeah, 640 then 480. That's because the window we got up is 1280 by 960. So that's dead in the middle, so that's fine. And if we move this to the right, let's move it by 100 to the right. Maybe we need to move more, to be honest. Maybe we'll have 300. So that should increase the x. But I wonder if that's too much. No, it should be alright. Yeah, so let's put us off the screen now. Okay, so I think that code's okay. Oh shoot. So where we're doing this conversion code here, that's all correct. So maybe the problem hey, you know how to capture and process exceptions. What do you mean? Like in C? And what do you mean by exceptions, like C++ exceptions? Okay, so what we're looking at there is this is probably correct. So What about I think we should view the cluster in local space. Yeah, so I think we should view the cluster. We should see what we're working out in local space. I think that's sensible. Cluster position in local space. That's what I kind of want to know, I think. So this should be -1 to 1 is local space, right? So it should be 0 because it's in the middle. %f. Yeah, if access violation or something occurs. I don't know, in C you don't have exceptions, right? You just get error codes that come back. And I don't know what, like, exceptions aren't really a good way of handling errors, right? In Windows program you have Windows exceptions, right? And you don't have those on Linux. So there's special Windows exceptions in C or C++, I forget. These don't exist. The dereferencing a null pointer, that's not an exception. Like that's you might get a signal for that. You'll get segfault, right? So you get a segfault signal. So basically how we handle it in this project is whenever those things happen, signal yeah. So if a segfault happens, meaning you access out of bounds, sorry, if you access a page that's not mapped, then we handle that. And then if you get an interrupt, also we handle that. Yeah. So basically, like if the program crashes because I got access out of our memory ranges, I have a crash handler, and then we basically like print out this call stack in the crash handler. It's already showing up. Anyway, can't find it. It's somewhere. I forgot where it is. Is it in main? I was just there. Yeah, so basically we if the debugger is attached, we do a breakpoint. If not, we point a same message saying, you know, it's crashed. And then check the stack trace file, and we get the stack trace and log that out. You'll have to collect some basic debugging info, such as what? Like, yeah, you can get a stack trace. You can also do yeah, other than that, you can maybe get a core dump or something. Okay, so the local space position is actually wrong. That is really wrong. It's not that wrong. It should be all the way up there. So I need to pronounce some. I need to get this proper then. It should be 0. Cluster position. Cluster position. Right, so saying 0.5. So it's in the middle of the volume. That's in unsigned norm space, so from 0 to 1. So that's correct. This variable is correct. Or did I do the wrong conversion? I think I did the wrong conversion to signed norm space. Did it the wrong way around. Damn it. Yeah, that's why I did the wrong. So I did the wrong conversion here. This should be times 2. Take away 1. So that's a problem. Then that'll get you in local space. So this should then be 0. Yeah, there you go. Nice. So that means now, if you have a cluster, we've got that position in local space, correct. So we've got a volume, like a 3D volume. And we've got that point in the middle now, 0. Left here is -1, right here is 1. Down here is -1, up here is 1. So when we process the top cluster, which is LOD 0, that is correct. Now, what is it in view space? I'm interested to see that. Because, yeah, it should be like, yeah, 0, 0, 128. Why are all my spheres over here then? That seems weird. So I feel like, let's go to that, let's go to that Raytracer now. Raytracer tile, I think I call it. Yeah, so there's a debug view when you have spheres in your, right, but instead what I might do is say, hey, if it's been allocated some kind of spheres, this can help me debug it a bit more. Then we're going to print out blue, basically. I'm not seeing any blue anywhere. Wait, no, it should be... Oh, okay. Yeah, we should be seeing some blue somewhere, but I'm not. Very weird. But we just enabled that. I think the spheres count can be just upped. Yeah, it doesn't really count. It can overflow itself, I think. Okay. Yeah, so what is it when we get it into this space then, right? So we go, so when we get into screen space, where is this cluster apparently? Right, 640 left, 640 right. It's basically non-existent now, which is a bit weird. Um, yeah, that's weird. So at least we now know we've got this thing in view space, that's the correct number. What am I trying to do here? Half dim-x view space. Yeah, should I see these numbers? Oh my days, what's going on here? Like, these ought to be something. Right. Let's read that. So this is showing the size of... Okay, so apparently it's 128 cubed in view space. So how the hell do we lose... Oh, we make them... It's 128. Oh, it's 128 in view space. Ah, I see. The size is 128. So scaled at 256 is 128 as the half extent. It is 128 away, so it's going to be divided by 128. Right. Is there something wrong with that? Yeah, but it should at least be a couple of pixels, right? Offset, and it offsets, gets the two corners. Yeah, maybe we just need to increase it a bit. Or bring it closer. So let's just bring it to about... Let's bring it to 32 away. And then let's give that a go. We're still not seeing any type of width on that at all, which is very weird. So I guess it's this important corner selecting. Am I right by that? So how this code works is you've obviously got this cluster, but you want to draw the bounding box around it. Now, the thing is about the perspective projection is the closer you are to one of the corners, the stuff that's sort of closer to that side will sort of warp more. So stuff's closer to here will warp more. That's closer to here will warp more. So if you have your cluster, basically, if you take the vector from the center of the, the origin of view space to here, which is basically the position. That can tell you which corner you need to, which is your important corner, and what is your other important corner. And yeah, this one needs to be your close closest X, right, to the camera, so it needs to be your furthest away X to the camera. And then you can use those two to basically make the bounding box, kinda. But maybe not in this case, because as we've just seen, maybe we need to sort of change that a bit. That's how I got the code working right now. Yeah, I need to get some debug drawing after this, so I can see these variables easily. Right, so let's print out this offset thing. Okay, I did something. I managed to get into the endless loop of fitting text into the console after writing an old pointer. Nice. Did you use the signal thing? The sig actions stuff. Okay, so we got 0, 0, then 128. Right, that's definitely a problem. So I guess this is the case where I've handled... of course. So this sign, problem is it gives 0, doesn't it? So sine is equal to 0. If sine x equals 0, literally 0, we'll make it 1. Is there a way to do that easily? Branches. Because it could be -1 or 1. I could probably send a better sine function. Wait, 2 seconds, just need to do something. Be right back. Right, welcome back everybody. Oh, my phone's in my pocket. Just can't see the chat. Right, oh, use sig action function. Excellent. Well done. Yeah, so the thing is you have to be careful about that sig action is to not cause another seg fault, because then you'll be bugged. Yeah. No, you can't continue running. Yeah, I think you might be able to recover in a very elegant way if you know your program very well. But I don't think it's possible for like massive programs to do that. Um, basically. So if it's greater than or equal to 0, then 1. If not, -1. So we'll do this manual sort of sign function because we want this specific behavior. Kind of a shame. No part of me thinks I should make a different sign function for this behavior because I actually needed to. Oh, whoops. Cool. So that means it should work in some way. Right, so we're getting some actual sizing now. So can I put it back at 100? No, it's probably not good. Let's do it at 64. Okay, so given preventing a double signal could be done by checking the stack variable. Yeah, exactly. You're on it. If you've already crashing, then yeah, you've got a fatal there. Okay, so apparently my left is at 468. And my right is at 270. Still, it doesn't make any sense. Why doesn't it make any sense? So let's look at this important point. Let's look at those x's and y's. And the z as well, I guess. So the important corner is 0. So it's just one of the corners. So that is 128. And negative 64. That's a bit weird. And then the other important corner should be negative 128, that's fine. But then 192, that seems kind of okay. What's this half z in view space? Is it really that big? Also, oh no, I've scaled it really big, haven't I? Yeah, part of the problem is I've scaled it so damn big. There's kind of fruit, yeah. Sure, I guess with some of the maths kind of falls apart. Let's just do 32 then. Okay, so we take that 5 to 9. So what sort of number are we talking about? So it's 640 is halfway, isn't it? So I did 640, take 529. That's 111. And then if I did 824, take 640. Yeah, so it puts us kind of about even in the middle there. But for some reason, the top and bottom is still not sorted out. So why is the top and bottom 0 on those two sort of on that? What is this? So I'm debug printing that in the final unit there, the half wire dim. Pretty sure we looked at that and it's 128, right? Half wide dim is 16. Huh? Right, let's put that one there and let's put the Z. Are there intrinsics for locking, such as interlocked intrinsics? Oh yeah. They're just atomics. They're in the they're in C11, or they're available as extensions. So you've got atomic C11. Oh my days. C11 atomics. Yeah, so you got this sort of, it's built into C11, and you can do atomic load and store and all that. Fetch add. Then you've also got GNU atomics. So if you're not using C11, using anything less, they've got their own sort of version which you can make wrappers around. Yeah, I'll just use C11s. Alright, let's just take a look at that. So I need the Y and Z ones. Use the C23. Oh ho ho. Right, 16, 16. Excellent. Okay, so we're getting deep values, which kind of makes sense there for those dim, half dim ones. So Y O Y. Yes, Y O Y. Is my Y missing? Y O Y is my Y. 0. My sine. Yeah, it's still 0. What's up with that? This offset is 0. It's just that times that. If it's greater than or equal to 0, 1, if not 0. What is going on? Alright, let's make the Y column sine.y. See what happens. That's 0. That's not right. Oh, damn it. Is there something wrong in the compiler? That can't be good. Should we debug that quick? Third party HCC. Wait, no. Yeah, it's in there. Where's the build settings? Cat. Oh yeah, sorry about that. Okay, that's why it wasn't showing up. So on launch with debug AST. Do I need to do -L, isn't it? Oh, -I, sorry, that's what I meant. -I source. Right, so there's the AST. Let's dump that to AST. By AST dump. .txt. Crying out loud. There's a type I'm not handling as a constant. It was going so well. UI matrix. MolVT. Got something in there. Yeah, I think there's something up with my compiler. Let's double check that. So if I was to say sine dot x and then sine dot y. Yeah, so we're getting a 1 through now, which is what we expect. And the y-axis has some content now. So there's some compiler bug here. Sudo check compiler bug. Y field is not being set properly using ternary operator for some reason in initializer. I don't know why. Is it this because it's a macro? It can't be it. So if I do that, does it fix it? It breaks other things. Yeah, you can use the atomic prefix and you shouldn't have to do anything for loading and storing. It might do automatically, but it might be good to explicitly use atomic load and store so you sort of show the intention. Yeah, I'm not sure if I like it at the type level, to be fair. Because it's just different instructions. Yeah. Okay, so now we're getting the correct bounding box. So that's all great and everything. So the next thing we'll look at is like, we need to now change the code for the spheres. When the spheres get binned, there was also the same bug when we take them from view space. Is that right? Cluster. Yeah, here's the same bug. So we, instead of doing so we put this unsigned norm space from 0 to 1. We've taken it to signed norm space -1 to 1. And I did the conversion the wrong way around. So we just need to sort that one out. I don't think that's the only problem though, but let's just give it a go, see what happens. Alright, now we're seeing no spheres on the screen, which is always a not. So we'll print out the bounds and see what we got. Must be snarky, why is ray tracing? Because I'm trying to render spheres using compute only. So, and also, oh my days, it would probably be good to also do some ray tracing anyways, do some lighting. So, yeah, also I want to render spheres using a projection, or ellipsoids if you will, using a perspective projection. So the only way that I could think about doing that is by tracing rays, so that's why we do ray tracing as well. Raytracing is the hip new technology that is mostly just marketing babble. Yeah. Yeah, this is not using hardware ray tracing. It's using yeah, it's just all it's 100% done in software. Yeah, because on some cards, ray tracing hardware is there's some hardware assistance, but there's also a lot of software in it as well. Nano's the new hardness. Yeah, it depends. The new hotness is obviously AI and machine learning, isn't it? But yeah, because Nvidia is all about that. Right, so we're seeing that they're kind of off the screen for some reason. So that's not what will. Oh no, that's in view space. No. Yes, that's in view space. So is that? No, that's in screen space. Okay, so what am I looking for now? Yeah, so what I want to try is I want to nick this, and then I want to like just see what actually is position in view. Let's do the local space one at the moment. So what we have is this volume, and in local space it's obviously signed norm coordinates -1 to 1. So we should have these spheres that exist from -1 to 1 ish, around about. And if they don't, then something is wrong, because we've got a full set of, yeah, something's clearly wrong. They're all kind of negative 0.9. Some of them should be that, but they're all kind of there. So they need to be a little bit, they need to smoothly go. Right, you've got a 4x4 by 4 set of spheres. If this is -1 and this is 1, you expect these guys to be close to 1 on the x, right? And these guys are close to -1 on the x. So that's what we're kind of expecting. Those neural processors a bit, it's a third. Yeah, so Nanite is the, yeah, it's the, essentially the sort of, is the dynamic level of detail streaming technology, isn't it, basically? So they have all these, like, they take an asset. They take an asset which is like very high poly, and they'll offline they'll turn it all into clusters of 256 polys. No, that's not even of triangles. And they've essentially got an LOD tree, a bit like the system I have designed with these spheres. They've got this tree of level of details of these clusters, basically. So they're able to effectively have different parts of the mesh be at different levels of detail. So this arm can be further away from the screen and be a lower level of detail, and this one could be closer and be a higher level of detail, basically. So that's what Nanite does, but with polys. It's still running like crap. Yeah, games do a whole lot now. They do so much now. So, and a lot of the time they try and push really good visuals at low frame rate because they're what they want to. Because pushing high visuals at 60 FPS is kind of difficult. It's a lot more manageable when you have 32 milliseconds, basically. So when they do demos and that, yeah, expect 30 FPS on a good card, or maybe, and then for the best card, maybe 60. Because something you also have to remember as well is a lot of developers use the best cards to develop on. So why is this in the wrong? So what we're doing for this project as well is we're actually using a mid-range card. Nothing that's too expensive. So hopefully this game should just, it's going to be basically built for a mid-range card rather than a high-end card. And then later on I can do the high-end stuff, I guess. It's also going to take me years to make this game, so there's that too. So this view space thing. So this local space thing is just well off. Well off. So let's take this cluster bottom left in local space. That should literally just be -1. And if it's not -1, there's a problem. But I guess it's probably this offset coordinate is just purely wrong. Yeah, okay, so they all start off at -1, that's good. So the problem is this offset coordinate is just pure wrong. So it's sphere coord. That is literally 0 to 3 inclusively. Then this sphere dim in local space. I think that is what could be. Well, it must be the problem. Anything that's left over. That's in the x coordinate. So there's the offset in. Right. Oh, 256. Okay. Don't mind me. Right, in cluster space. So cluster's 4x4x4, so this would be. Wait a minute. So sphere coordinate is in cluster space. Then this is in local space. So you need to get sphere dim at level of detail in cluster space. So effectively, this is at the highest level of detail. That is what that one is. But as you bring it down, cluster LOD, so if it's 0, shift left. Well, shift left by, or right rather, data LOD count take that, take 1. So I need to shift 7 or something. So 2 divided by 1. And then it would just be 2. No, we have to get some division in here. Uh, hmm. Yeah, I think that's right. Let's give that a go. These are everywhere. Right, let's debug this variable again, make sure it's right. Oh, we're seeing stuff in my face. It's looking alright. Just a bit flickery. So these are still being a bit too far, I think, because they're going outside the cluster. It's a little bit too much. What is that? Is that a float? It's a float in it. Right, so it's 1. 1 is too much. We should be expecting 0.5. Because you'll be -1. Wait a minute, you'll be expecting minus... So you'll be expecting essentially -1, 0, minus 0.5. Wait, is that right? Yeah, 0, positive 0.5. Then you offset all of those by a half of a sphere and get them all in the middle instead. Something like that. So the offset should be 0.5. Guess it could be that +1. Hey Regilla, how's it going? Awesome, good to hear, man. Oh, it's even bigger. 2. Guess that does need to be -1. My maths is failing me. There we go, there's a cluster in my face. Just dancing all over the place is all. Okay. So, given we've got this boy now, let's check the variables properly now. Gonna have to work on my nerves primitives, then surfaces today. Sweet. Doing the seam cell. Oh, well done. Ghost Goblin. Right. Yeah, then we offset it by half. Excellent. This is good. So it's negative 0.75. Well, it's a positive. Excellent. So these are all correct now. But for some reason we're dancing all over the place when it comes to wait, what was I testing? The local space ones. Right, can I check my view space? Sorry, my screen space stuff now. I don't understand why it's flickering that hard though. Like, it's not like there's tons of tiles getting filled. Sorry, spheres that fill up tiles. So we are getting some negative stuff. But that should be alright, we handle for that. Because we use floats and then we use silence. We did print out unsigned here, but let's not worry about that one. Oh no, but we climb it. Ooh. Hmm. No, it's a tile-based. It's a software tile-based renderer, but we use the tiles. It's a tile binning strategy, so we ray trace where each pixel in a tile has a list of spheres to check against, basically, in here. So we've already had this working in the past. We've just got the new LOD system we're hooking up. But yeah. something is a buggered. And I can't figure out why. Just yet. So what might the problemo be? Let's look at the data. So the spheres make it on screen. Some of them go off ever so slightly on the bottom half, but that's just about it. But they still show up on the top, right? So yeah, none of them go off. Interesting. What am I seeing? Oh no, that gets close, that one. Let's have a look at it. Yeah. Yeah, I think the bounding box is a bit messed. That they're definitely over conservative. So let's go to the tiled ray tracer and do the debugging view. Well, we can see these tiles and they'll show up blue if they have a sphere. Right, they all have spheres in. So this leads me to believe that there isn't a problem. I don't know. Maybe the sphere data is changing every frame. Should we try and select a tile? See, you know what I really need? I really need... I can get the mouse position passed up into the shader. I can do some, if the mouse is over a tile, checks. So what's fine about LOD? No, because that code no longer exists. See, I'm just plugging in the new system basically. We could print out the screen bounds. I do have this code. So yeah, I need to replace all this code with just a simple API I can call from any shader which renders a box or a line or whatever. Right, so we're seeing the boxes pop up now around the things. But again, why is my UI renderer running? Did I enable that accidentally? Bad UI renderer. I don't know if that could be causing my problems, you see. No, okay, it's not. Ray Max, what about it? Yeah. Fine. Yes, it seems like the input data is just noisy. And I don't know why. So it could be to do with basically the allocation code and then all the binning code. This is the BVH builder code. Just skipping pi, right? So we go over all these guys. Right, should we check if we overflowed? Okay, so I think what we're doing is we're writing to the same index as another sphere and overwriting it. That's why some of them exist, some of them don't. Something like that. So that means... So we also printed out the yeah, let's print out this cluster box and see how big the cluster should be the size of the screen or something. Right. So the cluster's not the size of the screen, but the spheres are like, hey, I'm the size of the screen. Or they fill the whole screen. That's a problem. So obviously that's why we're only seeing the ones in the middle actually stay consistent, right? Okay. Now I know. So why? Okay, so this sphere radius, that seems sensible to me. You've got the dim level of detail in local space. You're saying divide by 2, that makes it a radius. Um, oh no. Oh no, it should be right. Okay, let's avoid all this spam for a moment. So we printed out the size of, and they were 16. What is the size of this? So that the cluster's bounding box was 16 in view space. So what is that? Hey, son of Divine Fox. Not doing bad, my friend. We're just getting the first cluster actually showing up on screen proper. But it's kind of dancing all over the place, so we're trying to figure out why that is. But yeah, how are you doing? So it's 8 instead of 16. That's saying that it's half the size of a cluster. Something is wrong there, that is for sure. So we take... So in view space, let's take the y-axis. Wait a minute. This here. Yes, that's 16, this is 8. They're both sort of a half... They're both like a half dim, you know, that's a radius. That's half of a box height. Um, Technically the sphere should be half the size of that if the box is that size. Um, right. Yeah, it's still the problem is the in view space. Using the same view from local transform thing as well. What is cluster half dim? Then we can compare that to this thing. Okay, so cluster, oh my days, they're both the same value. Cluster half dim is 0.5. That's the half dim in unsigned norm space, but not snorm space, you know? And what we want is snorm. Not about snorm. That's what we want. Snorm space. Where is it? Yeah, prepare clusters. So this is, 1 divided by, this is unorm and then snorm. And that was the problemo. I'm doing okay, but I'm struggling with GLSL code. Oh no, I'm trying to normalize the viewport to pixel resolution in GLSL. Okay. So, are you trying to, what do you, normalize the viewport to pixel resolution? So what do you mean exactly? Do you mean going from clip space to screen space, or do you mean taking the pixel coordinates? So, okay, do you mean going from sign norm space, so -1, this is the screen, to 1, and then converting that into the actual resolution, which in my case is, oh wait, which in this case would be 0, then 1, 2, 8, 0. Is that what you mean? Like, which one do you mean? Alright. I think I can do that quite simply. So you've got -1 to 1. Yeah, -1 or 1. And then 0. Yeah. So your problem is, so basically what you've got is you've got assigned norm space, right? -1 to 1. That's horrible, yeah. 2, 1. So what you need, and then what you have on the other end is essentially an unsigned space, but it's not normalized. So you've got like, right? So you can replace this with W width, okay? So basically what you need to do is you need to convert this to an unsigned space, which would be 0 to 1. So that is, so we'll call this value, I don't know, let's call it I for some reason. So you take this value I, and you gotta multiply it by you multiply it by 0.5, then you plus 0.5. And that gets you from -1 to 1 space into 0 to 1 space, right? And then it's just as simple as then taking the result of this and then multiplying that by W. And then so that gets you obviously the X component 1, and you do the same for the Y component, and voila. So just write that out quick. You got X times 0.5, okay, snorm X plus 0.5, and that gets you unorm X, and then you do and then you want x in screen space, I guess. Equals unorm x multiplied by screen dims x, right? Or screen resolution, whatever we're going to say. Yeah. And that's basically it. Do the same for the y, and that will be your conversion code. Does that all make sense? Nice. Yeah, hit me up afterwards and tell me how it went. Oh, so now we're gonna use the proper space there. Good old snorm space. And we should have a cluster at the correct size then. It's still off. And we're still getting glitching here. But that one is to solve after. Right, so what's the problem now? Alright, let's right, so now we've got a cluster dim snorm says half the size of a cluster in sign norm space is 1, right? Because -1 to 1 says 2 is the whole width. So 1 is obviously the half size. That is correct. So what about the sphere? Not radius in view space. We had it. So that's the size of a whole sphere. I still think it might be off by a bit actually. Oh shoot, what's going on there? Okay, so this is the size of a whole sphere, so it's the diameter. So you can fit 4 of these guys in. You'll fit 4 of those guys in a cluster, right? So 4 times 0.5 gets you 2. And that's what we got. So, right, that seems okay. So what was the problem again? So for some reason the bounds ends up being quite wrong. So we end up printing out the boundaries of the spheres. They end up in a so we take the boundaries of the sphere in screen space. Let's comment on that for a bit. So let's re-enable these guys, and we'll re-enable. Alright, save that for a moment. Maybe we should look at in view space. Yeah, so the left here is 455, but the left obviously goes less than that, which is very weird. So should we look at some of the view space things? So we could look. So let's look at this component here. That should be negative something. Negative 32. Yeah, maybe we should look at the view space coordinates for some of these things. Or so look at half dim Y view space. And in the spheres, we'll look at the view space radius. So we should be able to fit 8 of those in. Yeah, so there's 8. So that's the radius of a sphere. Yes, that's the half size of a sphere. This is the half size of the box. You can fit 4 of those into this. So that number is correct. So we've got the correct size, like scalar values. The thing that we haven't got right is the bounds. For some reason. So what about the position? Yes, I think some of these spheres are overwriting other spheres in different tiles. This is why you're getting these glitches and seeing some of the spheres show up. These guys basically overwriting those guys. It's because this cluster isn't sizing up around the whole screen like spheres are being placed at. So that's where you're getting those glitches from. Sphere radius, that's fine. The position, maybe? I thought we looked at the position and was like, that's on point. But maybe... Yeah, we looked at the position for all those spheres and was like, that is... You know, it's perfect. But I think... Okay, so if we bring... this position in view space thing. Let's print this out. Um... So the size was 8, or the radius was 8, and the half dim is 32. Just got to remember that one. Vector UV frag coord. Divide by resolution. So geofret chord is already the pixel coordinate, right? So yeah, Eternal Divine Fox, I'm just taking note, is if you're doing GLSL, that is already the screen pixel. XY. So you want to map? Yes, that maps to -1 to 1. Oh, do you sorry, 0 to 1. You want -1 to 1. So you would literally just do times 2 -1, right? And that will get you, you take your U-norm value and then times 2, and that will equal to the sine norm value. Give that a go. Is that what you're looking for? So if I print out the view space position of the cluster, then we can see if the spheres go outside of the view space position. And if they do, there's a problem there, but I don't think they will. Okay. Right, so the position in view space is 0, 0, 64. So it's 32 half dim. So it should be 30 to the left, 32 to the right. Okay, obviously could have thought it was that. So, you know, so it's 32 to 96 along the Z. So we go negative. Yeah, negative 24 is the furthest to the left. Take away 8 is negative 32. Right. So something is quite wrong then. So if I take my most important corner, well, didn't we print that before? So that should be, oh, crying out loud. Oh, it's in screen space. In a view space. It could just be the different divide by z's that's causing it to be a different. Yeah, I think it's the divide by z's. Yeah, I think I can see it now. Yeah, so they're 32s, that's fine. So it's when we're selecting the right corner. See, that's our. Okay. So it's the way I'm deciding. So I've got this axis line bounding box in view space. So it's kind of like I'm trying to select the two most important corners. To then take into screen space basically. This is my screen space bounding box, and I've selected that corner down there and the one up there. So that's why it's not covered the whole screen, or the whole of this. So that's the code that's wrong. We need to think of a good way to do this. So what I've got is I've got this local space box, and I bring the position and the 3 basis vectors into view space. So that's what this code is here. Now, what I want to do is I now sort of reconstruct the basis, sorry, the half extent for a kind of a rough bounding box in view space. So what it is going to so it does kind of look like it is in screen space, I guess, when we're looking at it from like this, but it will go like that, then like that, then like that, and like that. So what we need to do is select the two most important corners. So if it's up here, you need to select that one and that one, basically. Because it will stretch. There's this one at the back. But as it gets closer to the middle... See, I'm trying to minimize the amount of corners I select, basically. But the closer it is to the middle of the screen, the more that the one in the background, as you can imagine, it's kind of like this, right? You want to select that corner and then this corner. Right, but obviously as this has got closer to the middle of the screen, I've selected this one at the back, but it ends up going like here when it's sort of in the middle of the screen. This corner goes like here when it's in the middle of the screen. So what am I... Yeah, so if my position in view space is less than the half extent, in what way? So the position you can think of as just a vector going from there to there. So from view space, center of view space to there. So if that position is less than like the half extent of the box in view space, if you will, along which dimensions though, how do you handle it for the x and y accordingly? What do you need to, how do you need to behave if that's the case? So if it's just up here in the middle, the box in view space, and you've got, you know, the x, like the vector to the middle of the box is less than the half extent along the x. Right, the x component is less than that. So, because the x component is like that, right, it's definitely less than that. So, how do you need to select the corners differently here? So your box is going to go out like that, right? But potentially this can go down like that, right? Potentially, right? So you still need to select your two most important corners would probably be this one and then this one. So it's when they're both in. Wait, I drew that completely wrong. It'll go like that, wouldn't it? It'll be that corner, then that corner. Because you say this is the min x and min y, this is the max x, max y. Okay, so it's when they're both in, you need to do something a bit different. So you're saying so that means your offset would always, so if Yeah. So if your center position of your cluster is less than half DMX in view space or equal to. And, well, I guess it doesn't really matter. Oh, cluster, yeah, here's a y less than or equal to half dim y in view space. Then what you need to do is somehow set one of these x components. And I need to put a comment here for this, otherwise I'll forget it. That adds a half, so that adds negative, that takes away, so that'll be at the back. It will it? No, this would be at the front, this would be at the back. So this will need to be, the z will need to be negative equal half dim z in view space times 2. So we'll get that to working and then we'll comment it. Oh boy, that didn't work. What's going on? What did we mess up? So it seems like we've gone and now messed up the, look at the corners. Left, bottom, that's interesting. That's kind of what we want to see. Yeah, I think that's got it right now. That's correct. So why? So what have we messed up exactly? So we've got a bounding box which goes over the whole screen, kind of. It might be using unsigned int somewhere. The signed numbers. Yeah. You do. That's just right. Clamp U32. These should be signed, I think, because it will underflow, and then it buggered it up. That's why, I reckon. No. Let's view this binning information. Right, 5 on the left, tile 5 on the x-coordinate left, 75 on the right, yep. The y-axis, though, is kind of clamped at 60 for some reason. But if we saw the cluster, it said negative 74, so it's up there, right? In screen pixels. So in tile space, this should be a low number. So something is a bit weird there. So your bottom left Y is buggering up for some reason. Yeah, so bottom left, we know that's fine. We're seeing the value. We know that's okay. So we're going to divide it by this. And then we clamp it. Run out loud. Is something happening unsigned? I don't know why. Let me do that. For crying out loud, why does that change anything? I think we had a similar problem with this. Why? So let me try that. Oh, it's not a compiler bug. This is an unsigned number. So this gets promoted to an unsigned number. Does unsigned division. That's why. Holy moly. That's the problem. We need to correct that in the other cluster code as well. Where's that? Yes. Then we tile these boys. Oh, these are doing it with floating point, so it's different. Okay, so I don't know why we're seeing this now, but we're seeing a lot better thing happening. Should we get the camera controls hooked back in and just have a fly around? So let's hook up the camera controls and just have a bit of a move around and see what goes on. Alright, so now we're seeing, oh, and then they shrink. And they grow big. Yeah, for some reason it just... Then when you get too close, it's because I've gone into the cluster. When I go into the cluster, it's like, I don't like this. So we get a negative Z value, I think. Yeah. And then they disappear when you go back around the other side, so they look thicker. And that's probably... Yes, because I need to absolute the... I need to ABS the... Where is it? When I translate the radius from local space to view space, I don't take the absolute. ABS F32. I didn't take the absolute of that. Let's try that out. Oh, it still bugs up. I need to take the max component. Or is it the min component? No, so I ABS all of them. It's a vector 3, and then I'll take the max element of that. So the thing is that obviously doesn't support non-uniform scaling. And yeah, because we turn it into a sphere, but we need to turn it into an ellipsoid if we want to do non-uniform scaling, which will do that in a bit. Right, so now that I'm seeing them sort of change. Now they sort of like puff out a bit. So I did it in my transform code. Right. Okay. Alright, how did I go about doing that here then? So I take the length of that transformed thing. And that'll be it. Are they meant to be that big? Something's a bit off, I reckon. I'm not sure if they're growing and changing in size. Let's print that out. Okay, so when the cluster goes off the screen, it does glitch out. Maybe that's it. Right, 13 point plus in view space. So they're all the same size. Exactly. All of them are that size. All of them. I'm trying to think, is that the right size though? Because they should all fit. If they're a quarter of, or if their radius is an eighth, then they should all fit with, not this snug, basically, not this sort of close. So I think that's a little bit off. Definitely not right. So yeah, I need to not take rotation into account. So we'll just do dot axes 0.x multiplied by that. ABS. I think that's right. So yeah, the radius. Oh yeah, I think that's right. They're a little bit off still. Oh no. Same problem again. Damn it. So when I change perspective, right, it's not the right. I'm not multiplying against the right. when I rotate it, the x-axis got a different value, like closer to 0 or something. In that case, it needs to be a different one. So it needs to be the sum of... Wait a minute. Mol s length of a vector, please. Right, that's looking like it. Completely cheesed that, but no worries. Figured it out. So now we've got, this is the first level of detail. So now we're getting the highest level of detail rendering. But this is not what it looks like. We're actually faking that the fact it's got a full set of spheres in there. It should actually only have spheres kind of in the middle, I reckon. But we're just faking it right now, just so we can actually debug one cluster rendering. But since it's got one cluster rendering now, the rest should be a lot easier. But we're kind of getting some glitching as soon as it goes off the screen. Is that right? No? 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 Alright, maybe when I... So the tile binning does bugger up somehow. I think it's when I get into the cluster. I think the Z becomes negative or something. Yes, if the sphere becomes negative... Okay, the ray tracer's like, I don't know what to do with that. Potentially. Right, I haven't got a cluster in view space. I'm gonna get that one back out. So I think let's fix that bug and then we'll drill down into the... We'll just get the rest of the clusters working. Alright, so we're gonna go ahead and oh, I could have just reused. No worries. I want to get the position of the plus. So if this if one of those becomes less than 32, I think it becomes a problem. And 32 is the half size of the the problem is I ain't got a good damn... Oh, there we go. I flipped the camera a bit, but that's alright. So if we try that, one of them... I thought there'd just be a little bit less than... half dim Y. Alright, what about those No, view space is fine to be negative. I feel like the SDF is not in pixels. Oh no. It's alright, you got this. Ah. The SDF is 9 pixels. Remember you're dealing with half. The radius value is wrong. Remember it's half the size, right? Radius is half. And do you remember the first parameter to that function p is the difference from the center of the object? Hey there, not so red, how's it going? Doing good, my friend? Let me just explain this and I'll be right with you. So remember that function, it's like p, comma, r. P is the position relative from the sphere in local space. Right, so it's in the local space of the sphere. So when you got this point on the screen and using this sine distance function, what P is the vector from that point to that point, right? So what you need to do is you need to get this coordinate in screen space in pixels, this coordinate in screen space in pixels, then it's this one minus that one. Yeah, because it's you do the coordinate you're going to go towards, take away the coordinate you're coming from, and that will get you that vector. And then yeah, and your radius obviously has to be in pixels as well. Remember, radius is half. Is half of a sphere, right? Give that a go, or hopefully that sort of helps you find your problem. Yeah, not too bad, not so red, nothing bad. Just yeah, we got like the first level of detail working again. And hey there, Tristan, how's it going? So we're rendering one cluster again properly, and able to orbit around it. As we get a bit too close to it, for some reason, the tiles like to cry, and I don't know why. And I don't know why. I need to figure out why it's doing it. Like, what is it? Like, it's not if I go off the screen. It's not if I'm too close. Oh, it's the important corner selecting. It's the same. Yeah, it's the important corner selecting. Damn it. I need that debug drawing thing. So I'm not selecting the right corners or something with a cluster. Right, I know the problem. Yeah, it's good, man. I can probably just... Shall we whack it up to see the full set of clusters? Or we'll go down to... Yeah, let's do that. I think I know the issue, what the issue is now. Wait, but that means the rest of them will bug out hard. That's alright. Let's just watch it. So spheres count. Okay, so we'll go up to this. We'll go down one LOD. We're not going to explicitly set. We'll only do it if we have. So we'll only select this cluster if we have spheres now, and you're at LOD. You're less than or equal to 1. See what happens there. Alright, clearly too much printing. But it will keep going all the way down, actually. Yeah, it doesn't stop. So I don't think there's any spheres at that one. That's a good point. Prepare. Alright. Maybe let's just... Maybe let's just prepare the spheres or something. Oh, sorry, just say it's got like 64 spheres, and let's just see what happens. See if we get a bunch of clusters. Right, if it's less than or equal to 1, let's say it's equal to 1. Okay, those spheres are too big. And it's bugging out super hard right now. So I guess it's also looking the same size as LOD 0. But we're seeing... Okay. Man, I think I need to get my debug drawing stuff like in, because it'll be really easy just to visualize some of this data. Like, hey, draw this box. Draw it on the screen, you know? So maybe next stream we'll be doing that. It'll just be way easier just to figure out what the crap is going on. You know, I got this box in view space, or I got this box in world space, draw it on the screen. Just so you can debug this a lot easier. Or I've got this line or something, draw it. But yeah, let's try and finish up this problem we're having. So the issue is, yeah, it definitely will. Like, at the moment I have to like debug print stuff out. Which is great when you don't have anything to compare it against sometimes. Or you want to see the exact value, but most of the time you just want to see it on the screen. I'm not selecting the right... Yes, I'm doing the selecting. Thing. Okay, so as it gets... Okay, so on the left-hand screen it's always bad. Is that right? On the right-hand side of the screen... It's not so bad, except for it gets there for some reason. Oh my days, it's so bad. Okay, something to do with those like important corners thing. Yeah, I just need a way to debug draw, man. Thank you so much. Sphinx Extremes, thank you. Appreciate it. Yeah, I don't know, should I just start... I might just start laying the groundwork for this drawing thing now. Because it's definitely needed. I just want to put up a box or something. So I guess like... Yeah, so I guess like the idea is kind of from anywhere in the game as well. But I guess we'll just make it specifically for graphics right now, and we can do a game side one later. So we need to have an API where we just say, and it needs to work CPU and GPU side, probably. So effectively in the graphics shared, you'll have so you want an API that works. Yeah, so I guess in the shared you have it forward declared. So you have all of the stuff in here. So I guess we'll just make a new section. Just make it the bottom. I've got to clean up at some point. But anyway, we'll just close that debug drawer for now. Let's just think about it. So effectively we want to have some form of like draw 3D, I guess. Point, and it just takes in a maybe you don't want to draw points, but maybe you do. So maybe we just call it draw 3D, and it's just a quick. It can just be used to quickly draw stuff. We could call it debug draw. Anyway. So in future we could probably make this probably like a tiled ray tracing thing, so maybe it wouldn't be so badly performant, right? When you just put a ton of stuff out. Because you'll be able to spawn it from shaders as well. But I guess we can just say like draw 3D point or whatever. Maybe point's not good one. So effectively, you want to be able to draw probably an axis line bounding box. And do we have an AABB? I don't know if we... Now the thing is though, what space does this need to be in? So in view space, yeah, probably we'll just say get it into view space. And that's all you have to do. So when you have in view space, then we'll just like ray trace against it or whatever the method would be to draw these things. So just push it on a queue. You'd obviously want to color as well. And you probably want to have yeah, and like a line thickness as well, isn't it? Yeah, so that's what I was just thinking about. It should be have like a bordered and a non-bordered one. Because all I really want is probably a bunch of yeah. I guess you could just do like a line thickness, and if you set it to infinity, then it's just a regular one, isn't it? Yeah, so that'd be nice to view that. But having it access line and view space means you're only seeing it, the view space one. Maybe you want to see an O oriented bounding box. So you just have that and then a transform. Maybe you just have a transform, and this will essentially be, so the XYZ will be the basis vectors will have the scale of the box. So that would just essentially be local. But when you're doing ray tracing, you kind of want to translate the ray into the local space of the object. So I guess we'll just invert the thing. You'll typically want to have that anyway. Probably a thickness on that. Okay. So like a sphere. Do I need to debug draw spheres? Probably not. A line for sure. We also kind of want like, so a line would just show like one point, like, you know, start and end point. But you also want a way, you probably want a way to draw maybe a wait a minute. Did Ike have a bunch of like shapes that had done, or was that only for SDFs? He does ray marching, isn't it? Not sure how ray tracing works. Are you looping over all the spheres in the compute shader for each ray? Well, so for our current renderer that we've got, so we currently bin it into screen tiles. So we've got our volumes, which is a 4x4x4 set of, sorry, a cluster is a 4x4x4 set of spheres, and a volume is a 256 cubed set of spheres, made up of clusters of spheres, right? And we have an LOD system where you have the lowest level of detail, L0, is one cluster, and that one cluster covers the whole 256 area because it's the lowest level detail representation of it, right? And essentially what we do is we bin those clusters, we bin the spheres into a tile grid. So when we launch a ray through the screen, we go through the near plane, right? This for that pixel or something. Each tile has a list of an array of spheres, and it just goes over all of those spheres. So we then do array verse sphere for all of the spheres in there. We are going to sort them eventually so we can do proper transparency. No, I'm just using a compute shader, full screen compute shader. Yeah. Yeah, I don't know if he did have any ray casting. No. Ray surface intersection function. Collection of ray surfaces for some common primitives. Use them to implement path tracer, UI clicking sound. So they return the position. They return the position of the object, right? Ray origin. So that's the radius of the sphere, the position of the sphere. So vector from ray origin to the position of the sphere. Yeah, I think I get what that is. Awesome. Yeah, ray tracing in a weekend's great. Yeah, they're interesting. It's yeah, the problem with ray tracing is difficult to get it fast, and there's lots of little tricks you can do. But lots of the ones that people landing on nowadays is to do stuff like temporally. So they use previous frames information and bring that into the current frame. I want to try and avoid all of that as much as possible. But we'll see how we go. Yeah. This function returns the distance to the closest intersection. Right. Okay, distance along the ray. Right, of course. Of course, it's ray tracing. Right, that's cool. So you got the sphere, you got the box, rounded box. I'm not fussed about that. But yeah, once we have the distance to it, we can figure out the point we've hit and how far away it is from an edge. It's not too difficult to do that. Disk. Interesting, you do a disk intersection. Plane. Even help you get a normal. Normal of rounded box, wow. It even gives you the normal as well. Ray direction. Right, what else do we need from this? Oh, good old wedge. No, we probably want like a cone, but I'm not sure if we want a capped cone. We definitely want a cap. We probably want a pointy. Well, it's rounded. We might want to remove one of the caps. Probably take that one. So that way we can do a nice vector, right? So we can be like, I got this arrow, and it's got this lovely cone sort of shape on the top, right? So that's what I probably want to use for that one. Yeah, these are getting a bit crazy now. Sphere 4, okay. Quite interesting. Yeah, it's kind of like a plane, the plane one, isn't it? But with a radius. Nice, isn't it? A disk renderer. Wham. It's pretty cool. Yeah, I think sometimes. Right. So we obviously want a line. Do you probably want to call that just like a vector, I guess? Maybe you also want to. So this vector. Do you want to? What space? in view space. Now we should probably have view space and then a world space one, and it automatically do the conversions there for us. Yeah, I think that'd be a good idea. Hey, Cypress, how's it going? Thank you so much for the rates, I appreciate it. Welcome, Raiders. How we doing? So we're currently working on a this trying to get in our LOD cluster system rendering with these sort of spheres that we're ray tracing against. But I've realized that we probably need a way to debug visualize a lot of variables. So we're just putting together an API that we're going to be using. So we're just figuring out the stuff we need basically for that, and I'll do this some other time. What happens when you want to render any model? So currently when we want to render any model, we've got like a volume instance, it's called a volume. We go down from the root LOD cluster and we check to see if it's at the right distance from the camera. If it isn't, we go down to the children, put them on the queue somewhere, and process them later. Then we process the children and repeat the same thing until we find one at the right height. We're also going to be doing some occlusion culling at this point as well. So if they're occluded, we can just stop processing it entirely. And save some processing time. And so what you're doing is you're seeing if you're getting the screen bounding box for that cluster and seeing if it is occluded or not. And then if it's not and you want to render it's big enough, you then see which tiles it goes over, and then you say, hey, these tiles need to make sure they allocate enough memory for this cluster to live there. And then after that, you've put this thing in an array, this cluster in an array, and then this cluster is in an array for clusters to render, and then you go over all of the arrays, all of the clusters in that array for every one of these tiles, and say, and basically take all of the spheres that live within there and do the same thing, get the screen bounding box and bin it in all of the tiles that one affects. Yeah, and then you ray trace against, now they're all binned in the tiles, you ray trace against them. That's what I do currently. I'm thinking I might slightly change the algorithm though, depending on how we scale. How we do when we scale up. I've still got to render a full volume yet and do the performance test there. Hey Prunus, how's it going? How you doing? Welcome. So we can draw a vector in view space, draw a 3D vector world space. Or we could just call it line. Vector's kind of nice though. You can also draw a point. So that draw point could probably be done as a disk. You're ray tracing against a disk. But then, so you'll bring it into view space, then ray trace against it, axis aligned. Yeah. So I think that's all we kind of want. Is those, Are those things enough? So that's the 3D ones. Then we're also going to have something in um, in 2D probably. Now that one is just going to use 2D sign distance fields. So you just do a bounding box. So it's obviously just all in screen space. So I could keep with the pattern and say ABB in view space. No, because it can't be in world space. You might have it in your own sort of space. Maybe it's just right doing like that then. Draw ABB. No, do we want to draw a sphere? Well, essentially a point could be just a sphere, right? That's all we want to. That's all we really want to draw, isn't it? So I guess just say radius. The border thickness. Sphere vector. We got a nice vector on that one. I want to draw a vector as well in this one. Oh, I didn't finish this. I'm doing good. Hope you're doing good too. I'll probably go sleep soon. Yeah, same for me, man. It's getting kind of late here. Like 10 to 10. ABB, border thickness, and a color. So with a vector, what are we doing with a vector? Well, you want to draw a circle. That'll just be a position. Probably want a border thickness in that one. Then a radius as well. So this will all be in screen space coordinates. So I guess we can just nuke the in screen space suffix and just put, you know, screen space. Right. And these should probably just be vector 2's, right? So you got a vector, you got a circle, so that can do a point and whatever, right? This can do obviously your vectors and have a nice little arrow tip. You got your bounding box. Do we want a... See, I don't really need the orientated bounding box yet, but if I need one, I can sort that because I haven't really got transform 2D. I have got it in the codebase actually, but yeah, it's under a different name. So I think this is all we want, all we really need for now. Yeah, so this one will be, so effectively what we'll need is to produce, so there'll be this API. Yeah, so this would be implemented on CPU and GPU differently. And you'll be able to, it will push it onto a buffer. And then we'll keep track of how many there are, and then draw them at the end of the frame on top of everything else. So we just need we probably need a structure. Now this will probably be put somewhere. I guess it'll stay here. So this will be the draw 3D shape, I guess. We can always just change the name. We need the shape type as well. So that'd be an enum. So with the shape type, what we're going to have is draw 3D shape type of axis line bounding box and orientate bounding box, sphere, vector, and then probably a count one at the end. So what can we do to sort of like, so I can't use unions. Instead what we could do is probably to have a, we'll just use we'll use an array of words and just pull them out. So it will just, so we'll just have this. We'll push on an array of words and pull them out. It shouldn't be too hard. So this means that we'll just have an array of U32s, plop them all in there, in the array. Should be alright. Same for this one, then we'll have a draw 3D shape as well. Draw 3D. Oh, sorry, 2D. That's what I meant. So draw 2D shape, ABB, circle, and then the vector. Nice. So it should be actually pretty minimal to get that done. Well, it should literally just be as easy as making a new one of these guys. We have our draw 3D buffer, draw 2D buffer. Oh, not 40. Not with that many dimensions. And we'll just instantiate these guys. So in the shared, we'll just say, hey, what's the maximum number of words? So draw 3D. Words capacity. Maybe we support up to, let's just do 65,000. U16 max for now. If we need more, we can always just change it. So basically, when you just instantiate the guys, draw 3D buffer. So we like draw 3D words capacity, and the word is obviously U32 size. 3D, 2D, good. So those are instantiated now. So all we have to do is CPU side, fill in, create these functions here. So we simply just take that bottom of this function, we'll just file, sorry. We'll fill this in, and then we've got to remember GPU side to also fill them in differently. So it should be as easy as having a little function called draw 3D alloc alloc words, and you say, hey, I want this many words to be allocated. So you somehow do that, and it returns null with failure. So you get your words. How many words do we want? Well, we need 3, 6, 7, 8. Plus 1, so it's 9 words. And you say, okay, well, if words equal null, then we just return nothing. And then you just fill all of them in. So you're like words, 0, and you write them all in manually. So this probably needs... So effectively what we need to do is, in the graphics globals, this is globally accessible to all of our shaders. And the CPU is going to upload a number, or 2 numbers, obviously, one for 2D, 3D. Draw, 3D. Draw 3D. Words count. Now so later on we're going to want to process this buffer, bin it into screen tiles or whatever, and then like handle it properly. But for now, this is probably good enough. In future we might do a bounding box or something as well. But that's nothing to worry about just yet. Because we're just going to want to get it working. So we're then going to want to have this number actually live not in the globals, like here. And every frame this will be initialized to 0. So when you do a render frame or something, one of the first things you do is go gfx.0. Now, after that, we can now bump allocate. And I don't know how we get the... yeah, we don't also upload into the full buffer either, it's something a bit weird. So yeah, so you get your insert index, and then you bump that. Then you want to say if that plus that is greater than or equal to draw 3D words capacity, then return null. So then you just got to somehow get the pointer. So I think what we want to do is probably have a CPU side representation of that somehow. So potentially we'll also have the draw 3D words array, and this is just going to live there for a bit. We're doing it for the 2D as well. Extern. Let's do another one for the 2D. Then, right. So essentially we just populate that buffer, and then we'll upload it to GPU. So you'll just return the address of that insert index, and I just gotta get these boys in here. Hey, it's Divine Fox. Done, finally figured it out. It was a stupid mistake. Yep. Don't worry, man. I do that all the time. You got this, man. Well done. So now you got the circle. The rest is easy because it's just copy and paste in the formulas, right? Wait, why did you do POW? Why do you need to go to the power of 2? Yeah, why do you need to go to the power of 2? Oh, are you calculating the SDF for a circle? Interesting. I just use IQ's wonderful set of articles here. You could just do length P, take R, right. Oh wait, it is, isn't it? It's because that's a dot wait a minute. That would be X times X plus Y times Y. Then divide by square root of. Yeah, interesting. Yeah, it does work then. Yeah, all you've done is written it in a different way. Yeah, you've just written it in a different way to the way that was presented. Bit more in line. Nice, well done. Yeah. Neat. I commend you, sir. Amazing. Yeah, I didn't get this application. I need to learn how to use it. It could be quite useful. So the draw 2D outlook is obviously just replacing the 3s with 2s. Yeah, so you just complete all these functions, fill in the rest. So this would just be like an as. Wait, it's like bits. Bits from F32 min in view space dot x, and you just sort of do all those. Y, Z, there's 3 plus. Then these are the maxes. Then you need 2 more. But I just remembered we're a bit off still. Border thickness, and then this one is just color, because that's just a U32. We're a bit off. We need to up by 1 on all of them because the first one is the header. And the header is that's draw 3D shape type. So it tells it what it is. Read the first word and it says, oh, it's the ABBB. So we'll just be doing that basically and filling it all up for the GPU just to consume and have, process all that data. And then we simply just have to upload it as well. So, do you have an upload somewhere? So upload, do we have an upload buffer? Yes. So another place we'll do, right before we do a submit, it's kind of a problem. We have to do it here. But yeah, so we'll basically get our words, draw 3D word. Right, this should probably be called G, draw 3D words. That would be better. So draw 3D words, get the things there, draw 3D words, buffer. So we're uploading basically ggfx, draw 3D words, count, E32, then it's just a mem copy into there from G draw 3D words, and again it's this thing here. So that's all uploaded. You then do the same for 2D, like so. And voila. So now they're uploaded to the GPU. So we just fill these boys in, and then they'll just be doing shader code from then on out, basically. Oh, and then obviously doing the GPU version of these, where they will... what's interesting is maybe all of this code could probably be the same, but this function would be implemented... Oh, no, it can't. Yeah, because you don't get pointers on GPU. Instead, you'll get back an index and you'll write it into a buffer, of which you gotta know the buffer to write into. So that will probably be a global buffer somewhere. The draw 3D words will probably be a global buffer that we know exists. Yeah, something to think about. But we can't share this code. We'll just have to have two different versions of it, which is fine. So that's 12 floats plus 2 more, so it's 14. Axes. One, two, and the final one is view from local dot translation. Four, five, six, 7, 8, 9, 10, 11. We've still got 2 more after that. So that's border thickness followed by color. Nice. Those are low caffeine values in my blood right now. Oh, thanks for the help. You know, you want to no, what my mistake was, yes. Float D equal pow x2 plus y. Ah, right, it was using the power. I see. Yeah, you shouldn't try and do maths when you're tired, man. It's not good. Your brain would just be like, Yeah, I was trying to do it too many times myself. Should listen to my own advice. So the sphere only needs 3 plus 2, so 5. Oh, we didn't put it in the global structure, did we? Let's do that. We've got to put those 2 numbers in there. Draw, words count, GFX, draw, right, and for the 3D one. That would be essential. So then the GPU can carry on that allocation because the count from the CPUs came. So it's came from the CPU. Say if the CPU does like 17 words, then the GPU can carry on from that number and put more onto the buffer, basically. So it'd be proper cool. Yeah, so we just want... This is kind of a good one just to keep copying, actually. Well, maybe not. Nah, sorry. Pause. Radius, then color. Color. Word 7 twice. Oh my days. Thank you, sir. Right, they're all good as well. It's not 14 words then, what is it? Plus the extra one for this. For the header, I forgot that. Because that's 12 floats. You know, 13, 14, then 15 for that one. Excellent. It's another piece of advice, don't rush. Just create more bugs. Alright, this is the same one. So the thing is, there's one where it's like in view space and one that's like in world space. So they would need to do the matrix multi. Oh, wait a minute. Why don't we always, yeah. So this one does it here. So this is pos equals transform mol v, no, mol p, yeah. So there's the view from, okay, so I ain't got a view from world in some sort of global place. So, don't mind me. Now we do. So, this is now G, but and we also need to do this kind of like ASAPs. There's a wrong constant in alloc 2D. Oh no. Thank you as well. Right, I'll remember that one. Thank you. So we're going, that goes there, which means that view calculation should be done as early as possible. Right, compiler says yes, apparently. All good. So we said that as early as possible. Okay. So that's great. So now in the drawing code, apparently this is 3D. Okay, thank you very much. So here we need to do that transform, and we do ggfx dot view from world, and pass them that, translate it, and send it up. So now it's all in view space for the ray tracer, just to be like, you know, I've got this. Except for when it's doing this OOBB, but it's got the view from local where it can do that there. This should, it will probably need the inverse actually. Yeah, it actually needs the inverse. It's not good taking the inverse. You know what? But then the user's going to have to do the inverse. And the user probably always has view from local. So I'm just going to leave it. I might just do the inverse here. I don't know. It's not meant to be a super performant thing anyway. But this just helps with performance, I guess. Oh. This helps with performance when the GPU, or as a GPU, I have to do it like many times across many threads, right? And it kind of be redundant. Right, that's nice. So we've got the vector version as well. Yeah. So vector, you need a repeat of that. 4, 5, 6, 7, 8. Wait, that's 6 words. This would be 9 words. 3, 3, 2 more, and then 1 more there, so it's 9. Take it easy, it's getting late over here. Gonna try and get some sleep. Awesome. Yeah, I should probably do the same soon too, actually. Thickness. Just want to get this all typed out, I think. I've got to do the GPU ones at some point, but I think I'll save that for the next stream. At least by next stream I'll just be able to have this debug thing working. It should be quite easy, just a ray trace that's not sort of optimized, you know. Should be quite easy. Good old switch statement. Off you go. So this needs to do that transform. So I need to do the 2 transforms. And there we go. So that's all of the 3D ones. So we've just got a couple of 2D ones. We'll get those done as well. Quite easy. So we'll copy this code. And then we'll just give it a bit of a refactor. So this would be the, instead of 3D, it's going to be 2D. And yes, so it's all in screen space. We need to allocate 2 plus 2 plus 2 plus 1, so it's 7. So it's min x, min y, max x, max y. Then it's border thickness. Did I call some stuff thickness still? What's thickness of that? Oh, it's the thickness of the line. Yeah, we'll need that, I think. Yeah, think about that when we go into the drawing. It can always be changed. Border thickness, and then color. So I'll sort these things here. Yeah, minimal. Cool. Right. ABB. Circle. So a position, a radius, a border thickness, and a color. So that's 2 plus 2 plus 2 to 6. Nice. Last one, which is the vector. Min max, that's not right. Don't you mean start and end? So you need 2 plus 2 plus 2 plus 1, 7. So start end. Thickness. And then a color. Gonna be good. Sweet. Yeah, so that's CPU side. So whenever we have anything that we're uploading from the CPU that we want to visualize, very easy just to just use this API and just push that on and the GPU can just render it. We are going to want to make these same functions on the GPU though. So from any GPU, from any GPU shader, we can just put them on an array, on the same array, and then they'll be rendered at the end of the frame, same frame, which would be very nice to see. We've obviously got to be careful where we don't spawn too many of them because you'll just overflow and it won't render them all and it'll flicker probably. But it should be quite easy to put it around an if statement. And very easy to see that way, which would be good. Cool. So on Sunday's stream, it'd be a nice chill stream basically writing this out, these functions for GPU, and then doing the ray traced implementation for the 3D drawing for these 3D shapes, and then the sign distance field renderer for these shapes. And that should be a nice easy API to use. We probably want to have some colors, which will make it nice. I've got a thing called like color. Oh, which one is that in GPU then? What did I do with it? It's in core. It's core shared. It's color 8, I think I called it, or color 32. So I've got this. So I could just use this instead. And then I can put a bunch of colors down where I'm just like, a bunch of predefined colors, which might be handy. Yeah, so we probably put a bunch of predefined colors where we just say color red, color purple, and you just get some kind of nice color, I guess. Or maybe it's like the proper name of the color. So it's technically correct. But yeah, that'll do. This needs to bring in the shared, I think. Right. So let's find somebody to raid. I should probably upload what I have right now. I should probably commit that. Even if it is just this. Is something working? Right, let's find somebody to raid. It keeps doing this, man. It just doesn't matter. Let's raid this guy. I guess he's doing game dev. Maybe. This is not CPP. Okay, have a good such weekend, everyone. I'll see you all on Sunday. Hopefully I'm in a good state, because I'm going to be partying the day before, so see how that goes. Anyways, have a good one. Thank you for coming later. Thank you for coming.